So question number 1 says that two particles of masses 1.8 kg and 1.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. The particles hang vertically. The system is released from rest. Find the magnitude of the acceleration of the particles and find the tension in the string. So we will need to make a diagram. So they're saying that there is a pulley. So let's assume this is the top of the pulley and then these are the strings attached to it. And then it is saying that there are two particles. Let's say the first particle is particle A and the second particle is particle B. So they both hang vertically and the first particle's weight is 1.8 kg. That means that they will exert a downward force of 18. The second particle, which mass is 1.2, thus will exert a downward force of 12. Now there is also tension in the string, and the tension applied on the right side of the string will be the same one on the left. So first we need to find out the direction of the motion. So we see that this 18 is greater than this 12. That means that the pulley will move downwards, like A will move downwards and B will move upwards. In that case, the tension with the string will try to move A upwards, and the tension in particle B will actually act as a forward force driving it upwards. The magnitude of this tension is the same. So in order to find the acceleration and tension, we will use the forces formula, which is that forward force minus resistive force is equals to the mass multiplied by the acceleration. So we will look at it in terms of the individual particles. So for particle 1, which is particle A, the forward force is the weight, which is 18, but the resistive force is the tension in the string. So you will write that as T. Then mass is 1.8 and then acceleration is missing. As for particle B, the forward force will be the tension in the string and the resistive force will be the weight of the particle which is pulling it downwards. So that will be 12. And then this is the mass and then the acceleration is missing. This acceleration for both particles is also the same since they're connected. So these two are simultaneous equations. So this minus t and plus t can be cancelled out, leaving the other terms to be added. So 18, that means that 18 minus 12, which is 6, must be equals to 1.8 plus 1.2a, which is equals to 3a. Divide 3 by both sides, we get that the acceleration is equals to 2 meters per second square. Now we can use this value of a and insert it into any of these two formulas. So let's say I use the first one. So 18 minus t is equals to 1.8 times 2. That means that 18 minus t is equals to 3.6, making t is equals to 18 minus 3.6, 14.4. So that means the tension is equals to 14.4 newtons and the acceleration is 2 meters per second. This was question number 2. It says that a particle of mass 7.5 kg starting from rest at A slides down an inclined plane AB. The point B is 12.5 meters vertically below the level of A as shown in the diagram. Given that the plane is smooth, use an energy method to find the speed of the particle at A. The first information that they've given us is that the plane is smooth. What that means is that there is no friction in the scenario in part A. Other than that, what we have to find is the speed of the particle B, and we have to use an energy method. So the energy method I always use is that the total work done by the driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against friction. So since there is no friction, this last component, the work done against friction, becomes 0. And since there is no driving force pulling the particle downwards, that means that the driving force must also be equal to 0. since the particle will move down due to its weight and not because there is a force applied to it. So that means that 0 is equals to the change in kinetic energy plus the change in potential energy. So we know that the formula for change in kinetic energy is half times the mass multiplied by the final velocity squared minus the initial velocity squared. That means that this is half times the mass, which is 7.5. They have not given us the final speed, so this is v squared. And since it is starting from rest at A, initial velocity is 0, so we won't add that. And the change in potential energy has a formula of mgh, which is the mass, which is 7.5, and then the gravity, which is 10. The change in height, now they've given us the change in height. So it starts from the top, which is h1, which is equals to 12.5. And then this is h2, where the height is equals to 0, making the change in height equals to negative 12.5. So a whole component is equal to negative 937.5, and half times 7.5 is, this becomes 3.75 v squared, meaning that v squared is, so when this goes to the other side, this becomes positive. So 937.5 divided by 3.75 is 250, making v squared is equals to 250, leaving v to be, which is the final velocity, be equal to under root 250. And if you want to be exact, that is equals to 15.81 meters per second. So that is part 1. So on to part number B. It is saying it is given instead that the plane is rough and the particle reaches B with the speed of 8. The plane is 25 meters long and the constant force has magnitude F newtons. So we need to find the value of F. So basically we need to find out friction because now the plane is rough. And other than that, they have given us the information that the final speed, which I'll write as V, is 8. The initial speed remains 0 as total in part A because they've not changed that. And now they're saying that this was the hill as they mentioned, and this was A and this was B. So this side, which was the height of A above B, is 12.5. And now they're given us the length of the plane, which is this. So that means that the hypotenuse, you can say, is 25 meters. And other than that, we know that the mass is equals to 7.5. So in order to find the force of friction, which we don't know right now, we can use the method again. So that is the total work done by the driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against friction. So again, this total work done against driving force, it will be 0 since the particle is moving down because of its own weight. But the only difference is that now, since there is friction, we will have a work done against friction. And we know that is equal to the force of friction, which we have to find, multiplied by the distance traveled. So we have the distance traveled, which is 25 meters. So that means that this will become 25F. That means 0 is equals to half the mass, which is 7.5. The final speed is given to us as 8. So 8 squared, and the initial speed is 0, so you won't write that down. Plus mgh, which will become 7.5 times 10 times the change in height, which again is negative 12.5 plus 25F. So let's find out the value of this component. This is 0 is equals to 240 plus, this will become minus 937.5 plus 25F. 697.5 must be equals to 25 multiplied by the force of friction. And if you divide that, this makes the force of friction equal to 27.9. So with that, we're done with part B. So on to question number 3. They're saying that there are coplanar forces of magnitude 52 newtons, 39 newtons, and p newton acting at a point in the directions shown in the diagram. The system is in equilibrium. Find the values of p and theta. So the key word in this question is the equilibrium. So equilibrium means that the force is acting upwards must be equal to the forces acting downwards, and the forces acting leftwards must be equal to the forces acting rightwards. So the 52 Newton force is acting upwards to the north, and the 39 Newton force is acting completely to the right. But this P Newton force needs to be resolved since it has two components. So let's in this direction. This means that it has a leftward component which must be equals to P cos theta and a downward component which is equals to P sin theta. So let's make the equations as per these two conditions. So for the first one, so the 52 Newton force must be equals to P sin theta, and the 39 Newton force must be equal to P cos theta. So we know that sin theta over cos theta is equals to tan theta. Now that would simplify these equations. So let's say I divide both of these sides by P cos theta. 52 over cos theta P cos theta must be equals to tan theta, since these two p cancel out and sin theta over cos theta remains tan theta. Now if we look closely, we have the value of p cos theta. So we can insert that value over here in the denominator. That means 52 over 39 is equals to tan theta, making theta is equals to 2 over 39, making theta is equals to 53.13 degrees. And now we can use this theta and use this in any of these two formulas. So I'll use this one. So 39 must be equals to P cos 53.13. So that means P is equals to 39 divided by cos 53.13, and this gives us the value of 65. So P is equals to 65 newtons. So with that, we have the value of P and we have the value of theta. So for part B, they're saying that a bus travels between two stops A and B. The bus starts from rest at A and accelerates at a constant rate of A meters per second until it reaches a speed of 16 meters per second. It then travels at this constant speed before decelerating at a constant rate of 0.75 A meters per second, coming to rest at B. The total time for the journey is 240 seconds. So for the first part A, we need to sketch a velocity time graph for the bus's journey from A to B. This is a 1-mark question, so that means you do not need to have a lot of working for it. There are 3 different accelerations mentioned in this question. The bus starts from rest at A and then it accelerates at a constant rate before it reaches a speed of 16. So that means the initial speed is 0 and the acceleration is given as A, so it is unknown, and the final velocity is 16. Now for the second part, they are saying that it travels for a constant speed, meaning the acceleration is 0. But still, it is still operating at a speed of 16, which means the final and initial velocity will remain the same, which is 16 as well. The time for both of these different parts is not given, but the total time is given. So now finally for the last part, they say that after operating for a constant speed, it starts decelerating, which is 0.75 A. That means the acceleration will be negative 0.75 A since it is decelerating, and the initial speed will be 16. Velocity will be 0 since it comes to rest. So the total time is 240 seconds, so we will write 240 on the x-axis, and the maximum speed that the bus has reached is 16, so we will write it like this, 16. So for the first part of the journey, we'll write the initial velocity and we'll mark it as 0, 0. And then at a random mark, we will mark it. Two dots together. So it moves for a constant speed. Then it moves at a constant speed for a specific amount of time. So we will draw a line. And now, for the last part of the journey, there is negative acceleration. So that means the gradient of the line will be negative and it will be downward sloping. For the first part, they've given us that the acceleration is a. Slope of the third line segment is lower than the first. It will be more flatter than the first segment. I will join the line from 16 to the point 240 on the graph. Okay, so for part B, we have to find an expression in terms of A for the length of time that the bus is traveling with a constant speed. So the length of time that it was traveling for a constant speed is this. But we don't have the individual time segments at these points. 1, which we can call T2. So in order to find the time segment, what we can do is that we can subtract the total time, which is 240, with T1 and T2. And we can call the length of time the bus is traveling at a constant speed as x this time. And T1 is this part. So for T1, we can use this information that we've written down. So we can use the v is equals to u plus at formula. So the final velocity is 16 and the initial velocity is 0 times a, and we can call this t as t1. So if we write it in terms of the time, it means that t1 is equal to 16 divided by a. Now as for this line time segment, we can use the v is equals to u plus at formula again. So the final velocity is 0 since it comes to rest, and the initial speed was this, which is 16, is negative 0.75 t. So that means when we rearrange this becomes 16 is equals to 0.75 t, and this t will write as t2. So 16 divided by 0.75 is equals to t2, which is equal to 64 over 3a. Sorry, I missed an a over here. This will become 64 over 3a. So if we write this again, this means that x is equals to 240 minus 16 over a minus 64 over 3a. And this is the length of time that the bus is traveling at a constant speed. For part C, they have said that given that the distance from A to B is 3000 meters, we need to find out the value of A. So this is the velocity time graph that we do in part A, and we know that the distance under the graph is always a distance. So that means that the area under the graph is equal to 3000. And the graph is in the shape of a trapezium, and when we incorporate the formula of area of a trapezium, that will be half times the height, which is in this case is 16, multiplied by this base, which is 240, plus this entire base, which we will write as x. I have used x because this is the same x we used in part B, which was the length of time that the bus was traveling at a constant speed, which was this line. So when we simplify this formula, this becomes x is equals to 135. We can substitute this in this formula. So 135 is equals to 240 minus 16 over a minus 64 over 3a. So So when we solve this, we get A is equals to 16/45. Question number 5, we have a particle A is projected vertically upwards from a point O with a speed of 80 meters per second. 1 second later, a second particle P with the same mass as A is projected vertically upwards from O with the speed of 100 meters per second. At time t seconds after the first particle is projected, the two particles collide and coalesce to form a particle C. Part A, show that t is equal to 3.5. So t is the time when both of the particles collide. So first we need to draw a diagram that shows the situation. So let's say this is the ground O, point O, from where the two particles are projected. So let's say this is first A, which is projected, and it is projected at a speed of 80. So that means u is equals to 80. The final speed is not given to us yet, and since it is operating against the motion of gravity, the acceleration will be -10. And as for particle B, it is projected a second later. So let's say this is particle B, and it is projected upward with a speed of 100. And like A, it is working against gravity, so acceleration will be -10. So what we can notice is that when both particle A and particle B will collide, they both will cover the same distance, since they are both projected from the same horizontal ground, which is point O. So we need to create two equations that show this. The kinematics formula, which is displacement or distance is equal to ut plus half at square. Now in this equation, t will be the time t, which is the time which they collide, and which will also be equal to the time that they both cover the same distance. So for particle A, the initial speed was 80, so this will be 80t plus half times -10 t squared. So this will simplify to 80t minus 5t squared. For particle B, we can write it as the initial speed was 100, so this will be 100. B was projected 1 second later than A. That means that it will take t minus 1 seconds for it to cover the same distance. So this will be 100t minus 1 plus half, and the acceleration was again -10, and this will be t minus 1 squared. So if I could simplify it any further, I would write it as 100t minus 100 minus 5t minus 1 squared. Now we will equate these two equations or formulas. So this will become 80t minus 5t squared is equals to 100t minus 100 minus 5 times t minus 1 whole squared. It will become 80t minus 5t squared is equals to 100t minus 100 minus 5. When we open t minus 1 whole squared, we get 2 squared plus 1 minus 2t. So this becomes 80t minus 5t squared is equals to 100t minus 100 minus 5t squared minus 5 plus 10t. Now this minus 5t squared and this minus 5t squared cancel, and putting all like terms together, we get 80t minus 100t. This goes on this side, as well as this minus 10t. This becomes minus 10t equals to minus 100 minus 5. Minus 30t is equals to minus 105. Divide minus 30 on both sides. We get t is equals to 3.5. For part B, find the height above O at which the particles collide. Both of the particles cover the same distance when they collide, since they both start from the same point O. So we just need to substitute this value of t into any of these two distance formulas, either of A or for B. So since A is more simplified, we will use that. So we said that the displacement of A, or the distance traveled by A, was 80 t minus 5t squared, and substituting this value of t, we can get 80 times 3.5 minus 5 times 3.5 squared. We get 218.75 meters. So this is the height above O at which the particles collide. So for part C, we need to find out the time from A being projected until C returns to O. So that means that I have to map out the entire journey of A from the time of projection till it comes down to the ground as particle C, since particle in A and B collided and became one particle C. In part A, we found out that the time of collision was 3.5 seconds, and that was t. Now for particle A, this t was 3.5 seconds, whereas for particle B, this was t minus 1. That means it was 3.5 minus 1. So it took particle B 2.5. But since they're asking about only particle A in this question, we will take 3.5 as the time it took from projection till collision. So this is point O, and now let's say that this is particle C. In part B, we found out the height of both the particles when they collided. That was 218.75. Now the question is that does particle C now keep moving upward, or after collision does it move back towards the horizontal ground O? Now for that we will use the conservation of momentum. So after they collide and become particle C, we can say that the mass was 2m, m being the mass of both particle A and B, and this v will become the final velocity after collision. So now we need to find out the initial speeds of both particle A and B before collision. For that we can use the v is equals to u plus at formula. So for A, this will become, initial speed was 80 and the acceleration was minus 10, and t in this case was 3.5, and that is equals to 45 meters per second. As for B, the initial velocity was 100 minus, and the acceleration was 10, and time was 2.5, and this becomes 75. These two are the initial velocities of A and B directly before collision. So we can insert these here. So this will become 45m plus 75m is equals to 2m times the final velocity of C. So 45 plus 75 is 120 m, and this is 2m. Dividing 2m on both sides, the m's cancel out. This becomes 60 is equals to the velocity of C after collision. So what that means is that directly after collision, particle C moves upwards, and then again the acceleration is minus 10 since it is moving against gravity. But now we need to find out the maximum height that particle C reaches before it starts moving downwards, and that will be when its final velocity is 0. We can use the kinematics formula, which is final velocity squared minus initial velocity squared is equal to 2 times the acceleration multiplied by the distance traveled. The final velocity will take as 0 and the initial as 60, which we found out here. 60 squared is equal to 2 minus 10 nx. So this becomes minus 3600 is equals to minus 20x, and if we divide minus 20 on both sides, we get x is equals to 180 meters. That means that C travels a further 180 meters above this 218.75. First, let's find the time that it took for particle C after collision till the point it reaches its maximum height. And for that, we can use the v is equals to u plus at formula. So we can take the final velocity as 0, since that was when it reaches its maximum height, initial velocity as 60, which was its velocity after collision, and the acceleration will be minus 10 again, since it is moving against gravity, and this is t. So 60 is equals to 10t. That means t is equals to 6. So now we know that it took particle A 3.5 seconds to go from projection to the point of collision. Then it took another 6 seconds to go from the point of collision to its maximum height. Final thing left to do is to find the time that it takes from going from its maximum height to point O again. And for that, we can now use this 180 meter which we found out. So C is now at its maximum height. So during collision, it traveled 218.75 meters. Then it traveled a further 180 meters. That means now it is at a height of 398.75 meters, is equals to ut plus half at squared formula. So x is 398.75. It starts from the top when its velocity is 0, so this entire thing becomes 0. And since it is moving downwards, now its acceleration is 10, and this becomes t squared. 398.75 is equals to 5t squared. Dividing 5 on both sides and then taking the square on both sides, we get t is equals to 8.93 seconds. Now all we have to do is add all the time periods that we have found. So the first 3.5 seconds for A from projection till the point of collision, then another 6 seconds to reach its maximum height, then the time it took to go from its maximum height to the point O again, which is 8.93. And that gives us the final answer of 18.4 seconds. Of mass 1.2 kg is placed in a rough plane which is inclined at an angle theta to the horizontal, where sine theta is equal to 7/25. The particle is kept in equilibrium by a horizontal force of p newtons acting in a vertical plane containing a line of greatest slope. The coefficient of friction between the particle and the plane is 0.15. Find the least possible value of p. Most important information that they've given us is that this entire system is in a state of equilibrium. So what that means is that the forces that are acting upwards must be equal to the forces acting downwards, and the forces acting rightwards must be equal to the forces acting leftwards. So for that, we will need to resolve the forces given in this plane. So first, let's resolve this p Newton force. Since it is acting in this direction, it means it has a downward and leftward component, and since this is parallel to the line of greatest slope, this angle will be theta, and that makes this p sine theta, and the force acting leftward as p cos theta. This particle's weight also has two components, which is downwards and rightwards. This will also have an angle of theta, and this will become 1.2 times 10 in order to get the weight, which will become 12 cos theta, and the force acting downwards will be 12 sine theta. Other than that, they've given us that it is acting on a rough plane, which means that there is a force of friction acting on the object. So we want the least possible value of p. That will be decided by the direction of friction. But we don't know in which direction it is acting, since we don't know whether this particle is going downwards or upwards. The least value of p will be determined by first making the equations which show a state of equilibrium. So what is the first condition? that the forces acting upwards must be equal to the forces acting downwards. That is pretty straightforward. So P sine theta is acting downwards as well as 12 cos theta. So that means that P sine theta plus 12 cos theta is equals to R, which is the normal reaction of particle. So that is one equation. Now we have the second condition, which is that the forces acting leftwards must be equal to the forces acting rightwards. One force that we have is this P cos theta, which is acting upwards, and this 12 sine theta, which is acting downwards. So the first scenario is that the particle moves upwards. In that scenario, friction would move downwards, making P cos theta equals to friction plus 12 sine theta, since they're both acting in the same direction. What is the other scenario? The other scenario is that the particle moves downwards, and in that scenario friction would operate upwards. And if we write that down in the equilibrium, that means that P cos theta plus friction must be equals to 12 sine theta, making P cos theta equal to 12 sine theta minus friction. So now we have to choose between these two equations. What gives us the least value of P? This one does. So now we will use this one and the first equation in order to find the value of P. They have given us the value of sine theta, which is 7/25. We can use this information to find out the value of cos theta. So let's say this is a right triangle and this is the angle theta. So sine theta is always equal to the perpendicular over the hypotenuse. So perpendicular must be equal to 7 and the hypotenuse must be equal to 25 for sine theta to equal 7/25. So using the Pythagoras theorem, we can find that the base is equal to 24. Now with this we can find out the value of cos theta, which must be the base over the hypotenuse, making cos theta equal to 24/25. So now we can use this information and plug it into these equations. In order to simplify these two equations to find the value of P, you will need to find like terms. So one is cos theta and sine theta, the values that we have, so we can simplify those. The other unknown that we have is P, R, and the value of friction. So we need to find out a way to simplify that. So we know that the value of friction is always equals to mu times R. And they have given us the value of the coefficient of friction mu, which is 0.15. That means friction is equals to 0.15 times R, and since this first equation is giving us the value of R, we can substitute it here in place of R, times P sine theta plus 12 cos theta. Now that we have the value of friction in terms of like terms such as P and sine theta and cos theta, we can write it in the second equation. So that will become P cos theta, and we know that cos theta is 24/25, is equals to 12 sine theta, and sine theta was 7/25 minus friction, and we found out the value of friction to be 0.15 times P sine theta, and incorporating the value of sine theta again, plus 12 cos theta, so 24/25. So now we can simplify this, and so this means P 24/25 is equals to 3.36 minus, and when we multiply 0.15 to both of these values, we get minus 0.042p minus 1.728. So we can subtract 3.36 from 1.728. We get 1.632 minus 0.042p. Taking this 0.042p to this side, since they are like terms, we get 1.002p is equals to 1.632, and dividing 1.002 on both sides, we get p is equals to 1.628 newtons, and we can round it up to 1.63 newtons. So with that, we have the end of question number 6. For question number 7, we're given that a car has mass Question number 7 is a car has mass 1200 kg. When the car is traveling at a speed of meters per second, there is the resistive force of magnitude k times v newtons. The maximum power of the car's engine is 92.16 kilowatts. For part A, the car travels along a straight level road, and part I of part A, first part, the car has a greatest possible constant speed of 48 meters per second. Show that k is equals to 40. So let's draw a diagram first. This is the straight level road. This is the car. It has a mass of 1200 kg, so that means it has a weight of 12,000. This is R. They have given us the maximum power of the car, which is 92.16 kilowatts, and that means that is 92,160 watts. And we know that the power is equals to the driving force times velocity. Now they've given us the power 92.160 and they've given us the speed. That means we can find out the driving force. So 92,160 is equals to the driving force times 48, and dividing 48 on both sides, we get the driving force to be equals to 1920. So we have a force of 1920 moving it forwards. A is an arbitrary constant given to us, meaning that it is a fixed constant which we don't know yet, and it is for friction, which is the resistive force. So we can incorporate it into the forces formula, which is forward force minus resistive force is equal to the mass multiplied by the acceleration. Forward force is equals to the driving force, since it is moving it forward, moving at a constant speed, meaning that the change in speed or acceleration is 0 as well. So this entire side becomes 0, making the forward force equals to the resistive force, which is friction. So that means that the driving force 1920 is equals to the friction. The formula for the resistive force is equals to k, which is an arbitrary constant, and v, which is the velocity at which the car is operating. So 1920, which is friction, must be equals to k times the speed, which is 48. That means k is equals to 1920 divided by 48, which is equals to 40. Part 2. At an instant when its speed is 45 meters per second, find the greatest possible acceleration of the car. We're given the speed, which we can put in the friction formula, and friction formula was equals to k, which we found out as 40, and times v, which is the velocity the car is operating, which is 45, and 40 times 45 is equals to 800. So we have the value of friction. Other than that, we are given that the maximum possible power of the car is 92,160, and we can incorporate it into the power formula again, which is power is equals to the driving force multiplied by v. Now we have the v in this case, which is 45. We can use that again. So driving force multiplied by 45, dividing 45 on both sides, we find out the driving force is equals to 2048. Now we can use these two facts again and incorporate it into the forces formula, which was forward force minus resistive force is equal to the mass multiplied by the acceleration. So the forward force is equal to the driving force again, which is 2048, and the resistive force is the friction, which is 1800. minus 1800 is equals to the mass, which was 1200, times acceleration. So 2048 minus 1800 is 248, and this is 1200 A, meaning that the maximum possible acceleration is 248 divided by 1200. For part B, for question number 7, we say that the car travels at a constant speed up a hill inclined at an angle of sine inverse 0.15 to the horizontal. Find the greatest possible speed of the car going up the hill. So first let's write down what we already know. So we know that the greatest power of the car is equals to 92,160 watts, and that the mass of the car is 1200, and we also know that the friction is equals to 40 multiplied by the velocity of the car. They've also given us the angle of the hill. So first let's draw the hill. Let's say this is a hill. So now I will substitute value such as theta in place of sine inverse 0.15 to make it easier. So let's say this is theta, this is the car, and now the weight will have two components. The angle inside will also be theta, and the downward component of the weight will be equals to 1200 the mass multiplied by the force of gravity, which is 10. So this will become 12,000 cos theta, and this will become 12,000 sin theta. There is a r, which is the normal reaction. Then since the car is moving upwards, this will be the driving force pulling it upwards, and since friction operates the opposite direction of movement, the friction will operate backwards. So now let's use this power given to us and find out the value of the driving force. So power, which is 92,160, is equals to the driving force multiplied by the velocity. Now both driving force and velocity are unknown, so in order to write it in terms of driving force, we will divide V on both sides, making 92,160 equal divide by 92,160 divided by V equals to the driving force. Use this driving force in the forces formula again. So forward force minus resistive force is equal to the mass multiplied by the acceleration, and they've told us that the car is moving up at a constant speed again, so that means acceleration is equals to 0, making the right side of the equation also equal to 0. So that means that forward force must be equal to the resistive force acting on the car. So in this case, the forward force is equal to the driving force, which is 92,160 divided by V, which we took from over here, and the resistive force will be the force of friction, which will be 40V, as well as this 12,000 sin theta, which is pulling the car downwards along with the force of friction. That is 12,000 sin theta. Now we said that sin theta was equals to sine inverse 0.15, so we can substitute that here. So 92,160 divided by V, and we can take this 40V to the other side in order to put like terms together. Minus 40V is equals to 12,000.15. So this side, the right side, is equals to 1800, and this side remain the same. So what we can do is that we can multiply V on both sides in order to cancel this V in the denominator. So this will become 92,160 minus 40V squared is equals to 1800V. 40V squared minus 40V squared plus 1800V minus 92,160 is equals to 0. Now we can apply the quadratic formula on this, and we will find that V is equals to 30.5, which is the greatest speed of the car going up the hill. which says that a particle P moves in a straight line passing through a point O with a velocity of 4.2 meters per second. At time t seconds after P passes O, the acceleration a meters per second of P is given by a is equals to 0.6 t minus 2.7. Find the distance P travels between the times at which it is at instantaneous rest. So they're saying that the starting point is a point O, and then the particle is moving in a straight line. So I'm assuming this particle is moving rightwards and just keep moving in that direction. And they've also given us another information that when it is at point O, the velocity is 4.2. And since we're taking O as the starting point, that means that when time is 0, the velocity is equals to 4.2. Now, we know that whenever we integrate velocity, we get the displacement. So in this case, displacement is the distance. So I will write that as distance. But we are given the acceleration. So that means that we need to find out the velocity, and we can do that by integrating acceleration. So a is equals to 0.6 t minus 2.7, making velocity equals to 0.6 t squared divided by 2 minus 2.7 t plus c. So v is 0.3 t squared minus 2.7 t plus c. Now, in order to find this arbitrary constant over here, we can use this information over here. So when we substitute the value of t, the velocity must be equal to 4.2. So 4.2 must be equals to 0.30 squared, which again becomes 0, minus 2.7 t, so 0 plus c. That means c is equals to 4.2. That makes that v is equals to 0.3 t squared minus 2.7 t plus 4.2. Now again, we need to integrate the velocity to get the distance. So distance is equals to 0.3 t squared, t cube divided by 3 minus 2.7 t squared divided by 2 plus 4.2 t plus c. Now in this case, I can already tell you that this c is equals to 0 because this is displacement. Now we know that we are measuring the distance from point O. So when the time is 0, the distance traveled must also be equal to 0. And if we substitute 0 for t, this will give us c is equals to 0. So d distance is 0.1 t cube minus 1.35 t square plus 4.2 t. So we have the distance equation. Now they're saying that we need to find the distance between the times at which the particle is at instantaneous rest. What that means is that we need to find out the time when the velocity is 0. So if you look closely, we have the value of the equation of the velocity. So we can equate that to 0 to get the time. So 0 must be equals to 0.3 t squared minus 2.7 t plus 4.2. So after using the quadratic equation, we get that t is equals to 7, t is equals to 2. So now we have the displacement formula, which is 0.1 t cube minus 1.35 t square plus 4.2 t. Other than that, we have the times when particle P is at rest, which is when the t is equal to 2 and t is equal to 7. Now we can substitute these two values for t back into the displacement formula and find out the distance traveled at these 2 points. So when t is equals to 2, the displacement is equals to 3.8. and when t is equal to 7, the displacement is equals to negative 2.45. So we started at point O, and then at t is equal to 2, we were 3.8 meters from point O. And then when t is equal to 7, we find that the particle is now 2.45 meters to the left. So if we were to find the distance traveled between t is equal to 2 and t is equal to 7, we would need to add 2.45 and 2.8, so we get this entire distance. So when we add 2.45 with 3.8, we get 6.25 meters, and this is the distance traveled between the times when particle P was at instantaneous rest.